Hey everybody, let's give this problem a try. So we have a amusement park car up here, initially at rest, so V is 0, and then it goes down the track. So we want to know the speed here, and then here, and then here. So one at a time. So there's no friction, there's no kinetic friction. There's rolling friction, but the work by rolling friction is 0. So the work by friction is 0. So energy is conserved. Okay, for all of the cases here. So I'm going to call this, let's say, E naught initially when it's over here, and then let's go with E at point A over here. So let's do this one first. Okay, so what's the gravitational potential energy here? Depends on where you pick the datum. Okay, so let's just try a few examples. We could pick the datum here, over here, or we could pick the datum here, or we could pick the datum here. There's no wrong choice. So how about we pick the datum here for this one, the datum. Okay, so if that's the case, how much gravitational potential energy here? It's mg, the height above the datum, and then the kinetic energy is 0, so then that's it. And then final, when it's over here, it's going at some speed, this fast, but then now it's at the datum. So then that's it. We can divide both sides by a non-zero mass. So then we have the speed. V squared equals 2gh, like this. But what value do we put for h? The height above the datum is, here to here is 50, here to here is 20, so here to here is 30. Okay, so that would be for the speed at A. Okay, now how about the speed at B? Now we have a few options. We can go E naught over here equals the speed at B over here. Okay, let's do that. So, and let's try something different. Let's pick a different datum this time. So let's say we pick the datum here. Okay, so initially it has gravitational potential energy, but it's at the datum. So 0 gravitational potential energy and 0 kinetic energy. So 0. Okay, then when it's here, it's going at some speed. I'll call this the speed at B. I'll call this one the speed at A. And now what's the gravitational potential energy? It's below the datum, negative. How far below the datum? 10 meters. Right, here to here is 50, here to here is 40, here to here is 10. So this is 10. Okay, and then solve, right, just solve for B, where this is 10 meters now. Okay, now let's go with at C over here. So then initial up here, and then final over here. And now let's pick a datum somewhere different. How about, let's see, how about here? Okay. My point is that you can choose your datum wherever you want. It doesn't matter. So if we pick here, initially, kinetic energy is 0, gravitational potential energy, mgh, I'll call it initial, where this is the height above the datum, 10 meters. Okay, and then final, when we're over here, we're going at some speed at c. And now what's the gravitational potential energy? It's below the datum, so negative. And then what number is this? Below the datum by 40 meters. Okay. And then solve for v. So then pick this up, move it on that side. Okay, and then solve for, again, cross that out. So v equals 2gh. Right, and then that is 10 meters, that is 40 meters. And maybe let's try this one more time. Same problem, let's pick the datum somewhere else. Let's say we pick the datum here. Okay, so then initially mgh, where this is now 50 meters above the datum. And then final 1/2 mv squared. And then now it's at the datum, so the gravitational potential energy is 0. Solve for v, where this is 50 meters. Note how it's the same here. Let's try this problem one more time, the same one. This time let's pick the datum here. Okay, so then I'll just jot it down right here. Initially, mgh, where we are 30 meters above the datum. That's 30. And then at c, we're going at some speed. And now we're 20 meters below the datum, minus, where this is 20 meters below, right? So let's solve for v, move this over on this side. V is 2gh, like this, where that's 30 meters and that's 20 meters. See how that's still 50? Like this is 50, like this is 50. So the point is, you can choose your datum wherever you want and you are correct. Okay, so I hope that was helpful. See you on the next video.